Welcome to Data Engineers Lunch number 2. Oh, sorry, number 13. Excuse me. I'm looking at a different number. Like, how is it number 2? We've done so many. Number 13. Today's topic for discussion is Introduction to Airflow, presentation given by Obi. I'm your organizer, although I'm looking for co-organizers. Would love your help. All you do as an organizer is you get to network and you get to build your career while you're helping get young guys like Obi to build their careers by presenting stuff online. And I encourage all of you, anybody who's interested in doing a presentation on Data Engineers Lunch, send me a message on the private message in Zoom, or you can email me if you'd like. And happy to put you on the deck. We're part of Data Community DC, which is a large community of data practitioners across several groups, as you can see. We're also called DC2. What do we cover here? We cover the get your shit together problem, which is how do you get data together, clean it, process it, put it in a bag, take it to the store and sell it. Pretty much. So, but we also cover other bordering things such as data analysts. What do they need? Data scientists. What do they need? And ultimately, data engineers' job is to figure out how to scale what data analysts and data scientists need. Normally, we would, in the physical world, say, hey, take 2 minutes to talk to somebody that you haven't met. And then normally, again, in COVID times, we've said to introduce new names, but we have so many new names, we're just never going to get through it. So after the talk, we'll just keep it open. You guys can chit chat and network, and we'll give time to folks to introduce themselves. Group rules: if you have a question, ask it. Be polite and courteous. You can use it as an opportunity to share what you know. Depending on the speaker, they may ask you to wait until the end of their presentation, but you can always put something in the chat. This event is sponsored by Anant. It's a company that I work for. We specialize on scalable global real-time data platforms involving Cassandra, Spark, and Kafka, amongst other technologies as they come along. DataStax is a partner and a sponsor. So is George Washington University and a few local sponsors in Chicago and DC. Also want to thank our organizational sponsors that make the Data Community DC Nonprofit Foundation possible, which coordinates activities across the DC area. Anyone looking for a job or has a job to offer, any events, meetups coming up that somebody would like to talk about?
Hi, my name is Michael Eichler, and I am happy to found this group. I'm currently a manager at WMATA, the DC transit agency, and we have a job opening for a business intelligence analyst, and it really is a lot of what a data engineering job, maybe more so than an analyst. So feel free to go to the WMATA careers website and look for the business intelligence analyst position. I'm excited to see what great candidates we're going to find. We just lost our last one. This is replacing someone who left on Friday, and we're really hoping to get someone on board ASAP. So thanks so much. Thank you,
Michael. And Michael, if you want, you can put the link in the chat so that everybody can see it. Okay. Awesome. Let's see, upcoming, you're always welcome to go to Data Community DC or the meetup website for Data Community DC. There's always events happening. This meetup is every Monday at noon. We also have another one on Wednesdays, which is more related to Cassandra, but it's called Cassandra Lunch. It happens every Wednesday, where we cover some topics related to data engineering, but around Cassandra. Anyone have anything else before we get to the talk? Okay, well, without further ado, I'm going to hand over screen share to Obi.
All right. Hello, I'm Obi. I am a junior engineer at Anant. Um, and today I'm going to be talking about sort of getting started with Airflow. Um, is my audio coming through?
Yes, we can hear you,
Okay,
Obi.
cool. So if you look at our YouTube channel, you will see that there was actually a previous data engineers lunch on Airflow given by Will Angel, who I think I see
Yep.
in the chat today. So Will, if at any point you have something you would like to add or say, feel free to just chime in. Or really anyone who's experienced with Airflow. This is really going to be more of a beginner's perspective, just getting started and um, figuring things out from the beginning. Sort of,
That sounds great. I'm taking notes to see what I missed.
well, okay. So we're going to start today with a little overview of just what Airflow is. It's a scheduling automation tool. It separates your tasks out and combines them into workflows. Very good for automating repeated processes. So if you have common ETL tasks like downloading new data from somewhere that you have to do every day, or you have your machine learning model that you need to retrain every single day or every month or however however often you need to replace it, Airflow can handle the automation for that. You write all your workflows up in Python. And that means that all your tools interactable via Python should work. So things like PySpark or machine learning libraries or um, like ETL libraries for Python, those should all work. Um, you can define your dependencies for different tasks within a workflow. So you can say, download the data and then do this, but only if your data is actually successfully downloaded. And then your workflows are DAGs, directed acyclic graphs of tasks, which means they can branch and merge, but no loops. You can schedule your workflows or execute them manually within the UI. For scheduling, you use either cron syntax, where you define the frequency using their own syntax, or Airflow actually has some frequency tags like daily, weekly, that you can use instead. And you can also monitor your tasks, how they're running, if they failed recently, and you can use it to view your logs of those processes as well. All right, so the principles of Airflow. This is just taken directly from their website. So it's scalable. It has modular architecture that can send out jobs to workers. Dynamic, since Airflow pipelines are defined in Python, you can actually dynamically define DAGs in code. It's extensible with a bunch of already existing operators, as well as the ability to write your own. And they don't explicitly know about elegant, but I guess that's true. It's so features. So the picture in the top left is just a bit of a DAG. So you can see it's just normal Python code with some specific classes and things that are that need to be defined. You can see at the bottom sort of the DAG UI, where it's defining your different workflows. It's telling you who owns them, whether they've been run recently, their schedule. You can see, I'm not sure if it's being covered up, but you can see the sort of cron definition for that schedule, as well as actions you can take, reload, run, delete. And then the features up in the upper right, everything's written in Python. You have your UI. You have a bunch of integrations with your operators and connectors. It's easy to use and open source. I believe Airflow originated as an Airbnb project.
Yeah, I believe that's right. Yeah.
Yes. So moving on to DAGs. It's directed acyclic graph, a group of tasks with dependencies as edges. It makes an actual graph. You can see an example down in the bottom right there. Your individual data engineering tasks combined together, they form a DAG. You define your dependencies as well as your tasks in the Python file. And then your DAGs can be run on a specific schedule. If you look in the last page, you have a run button there that you can also use to trigger them. But generally, you want to schedule them. And there's also a command line interface you can use to trigger them. And then over on the far right, you can see this is the schedule column from that same UI. You can see both the cron definitions for schedules and then also the tag at daily, which is a sort of like frequency tag to run it every day, which you could also define using that same cron notation, but you do not have to. Okay, so operators. Airflow has a bunch of operators and connectors to a bunch of different types of external tools. You can use ones that are built by others, specifically for those integrations, but you can also supplement them with your own custom written operators if you want to write your own, if you want to add functionality, a connection that does not currently exist, or if you want to just implement new functionality. All right, so for our demo, we're going to go through bringing up a Airflow instance in GitPod, and then we're going to run through some of the command line interface stuff for the tutorials, and we're going to look through their example DAGs to see sort of how they're written and how they work. So first thing we need to do is to install and run Airflow. And the first thing we're going to do for that is set all of our environment variables. And then use those to define a proper pip install. So what we're doing is we're installing Airflow version 2.0.1 to the specific location, Airflow, the folder defined here. And during this demo, we'll be looking mostly at the included examples and tutorials, just because I've had issues getting Airflow to load in new DAGs that I've written myself. I actually do have a couple. There's like this one is experimentation into getting the Spark operator connected, but Airflow is not picking up my new DAGs, so it's easier to run through with their example code. So the first thing we need to do now that we've installed Airflow is we need to get it to start up the database. I believe the default Airflow database is SQLite, which also limits your parallelization. But it is possible to run with a different database in order to get that functionality back.
Hey, Obi, there's a question.
So
Is the term operator akin to connector?
So not exactly. There's a connections tab inside the Airflow UI, which just allows you to define like your literal connections to external software, host, port, that sort of stuff. And then operator is actually a like Python library, which manages that connection and allows you to use the functionality from that tool. So if we look into this, this file here, the operator that we're using is the Spark submit operator, which is part of the Airflow, this bigger library. And it manages a connection to Spark and allows you to run Spark submit jobs via Python. Another question, I assume that I can run Airflow locally on my machine to manage tasks. Yes, so you can run Airflow locally. I believe it's also possible to put it up in, say, a Docker container or an external machine, and still get the ability to schedule tasks on local machines. And this question is currently scheduling a Twitter mining job using cron, but scheduling is pain in the ass. Would Airflow help in that? Yes, potentially. If you write up your workflows, you can do things like define number of retries, things like that, that cron can't currently handle without like external tooling. So I do think it would be useful in that. Airflow relies on Linux cron tab. What if I have a Windows operating system? So you can potentially run your Airflow in a Docker container. I don't know about scheduling tasks on Windows.
I'm pretty sure that you can use, if you're using Windows 10, it has Windows subsystem for Linux, which is Ubuntu.
Yes, I always forget that because I'm currently running Windows 7.
Yeah, the other is if you are using Windows below 10, there's also Cygwin, which and like Git Bash kind of has it. But yeah, you can eventually figure it out. I mean, like I don't think it's 100%. I'd have to double check to see if it's actually reliant on quote cron or if it's using an internal Python library to do everything. But I'm actually going to double check. Sorry, go ahead, Ubi. Yeah.
I'll comment there that it's not using cron. Airflow has its own scheduler.
Yeah.
But it uses the cron syntax. So if you're familiar with the cron syntax, you can reuse all of that for how you schedule things.
Okay.
Awesome. Thank you.
All right, so the next thing we have to do is to create our user. For some reason, their example is Spider-Man, which I don't know, maybe I'd trust Spider-Man to run my data engineering. Bringing up the web server. I'm not sure that's actually visible. Currently on port 8082. We don't actually need to bring it up there, but when you run Spark as default, it runs up on 8080 and 8081 with the master and worker nodes. So we need to pick a port that isn't chosen by those if we're running with trying to use our Spark operator. Okay, so good look at the Airflow DAGs UI. This. All right, you can see these are all their defaults. So we need a new terminal so we can run the scheduler. What is an Airflow provider? Well, I think providers is like not the same as operators, but a group of operators for a specific tool will fall under some provider. So you can see even at in the definition for Spark here, it's Airflow providers and then Spark operators.
Yeah, and I'll just chime in there and say that Airflow is designed in a modular fashion. So the core service is just Airflow, but there are, they call them providers, effectively modules for interfacing with other major services. So in this case, this is the provider for Spark, and it means you don't have to interact with the Spark API in great detail. They've got them for Google, AWS, etc.
Yes. All right, another new terminal. So just real quick, a look at the way that you would change your internal like location such that Airflow should load in DAGs from that folder. The configuration file for that is Airflow CFG and the base DAGs folder here. Change to the location where we are keeping our DAGs. And then also make sure to change the Airflow home environment variable. And then in order to add our DAGs to the environment, we would just run the necessary Python file. Oh, we're in the wrong directory. And of course, currently we're missing the proper library. But we can take this opportunity to look into DAG a little bit. So you can see a sort of tree view here. It's just a normal computer science thing. Any directed acyclic graph can be represented as a tree. You can also see it in the graph view here. Now we haven't actually run these tasks any times, so we don't have any of this data, but we can look at the code. There we go. So you can see the same way, just imports at the top, definition of arguments, creation of DAG, and then definition of tasks. And there should be something here that is defining the relationship between the tasks. Here we are. So this just defines that T2 and T3 depend on T1. And then the definitions for those tasks are also there. So first thing we're going to do Airflow tasks run. What is this? Okay, so in our first run here, we ran it at this time. We wanted to run sleep as defined, anyway, as defined here. And so Airflow took it upon itself to run prerequisite task print date. And as you run more and more of these, you can see all of your different runs laid out, provided it's actually running. Is that an error? Well, let's check. So it has stopped running, but you can see all of the component tasks have ran properly. You can also see a Gantt chart of the times that those tasks actually ran. There we go. More runs are starting to show up. Okay, so let's give it one more shot. What am I forgetting here? Well, something is having trouble, but you can see that DAGs will run out their individual tasks. And you can check the progress of those as they run. And then it also keeps a log for you later on. So if you were to come in and see a failed task at a certain date and time, you can go back and check those runs. And then the connections thing that I was talking about earlier has a bunch of these by default, but you can add new ones, you can edit them. So if we were connecting to Spark, we would create a new why is there only a Spark SQL connection? Could have sworn that the one here. That's odd. You can also use the command line interface. I do not know where these errors are all coming from, especially since it is actually running the correct thing afterwards. But anyway, you can use tasks list in order to print out the individual tasks that make up a DAG. Does Airflow take care of running multiple jobs of the same type in parallel? I believe so. So the default database for Airflow doesn't allow you parallelism. I think there's a message in one of these things that is specifically about that. Just with SQLite, you can't do it, but other databases that you can replace that with do have that functionality. Yes, you can set everything up so that you can do that, yes. Name client is not defined. So it's something to do with the, anyway. We'll just look a little bit at some of these DAGs. Okay, so basic ETL, you can see it's just a line of tasks. There's no branching here because ETL has to be performed in order. And if we go look at the code, you can see that what we're doing, create the DAG, and then using that, defining our extract, defining our transform, defining our load. And then defining our dependencies down here. Load relies on transform, which relies on extract. So if you have something different, like a different order, maybe extract, load, transform, or something like that, you define that relationship differently. And if we trigger it manually, do we have data we want to upload? I should have taken a better look at that. So we can see that's now running. Luckily, it has data already in, so I didn't have to generate any. Yeah, we're at 3 tasks, which are not finished yet. Okay, that was pretty quick. You can see that DAG run. And we can see all our separate information here. Extract took this long, it took this much time to run the next part, et cetera, et cetera. So I apologize for the technical difficulties on top of what I was already expecting, but hopefully something here will be useful to you trying to get Airflow up and running for yourselves.
Awesome.
So let's move into discussion. Oh, another question in the chat. When would Airflow be preferred over something like NIFI?
I can answer that, OB, if you want.
Okay, sure.
Yeah, so Airflow is and NIFI are two different things. NIFI, at least that's how I pronounce it. So NIFI is closer to like Flume or Kafka streams, where it has a internal DAG of work that it basically does tasks on to manipulate information as it goes through. And it's used for things like IoT, and just general, high transaction processing of messages. And I'm not going to go into, and actually that might be a good topic, NIFI itself. But NIFI is a different thing. Airflow is literally to run jobs that it could be a batch job. It could be that you kick off some task written in Python or maybe even written in Spark, Scala, but the Python wrapper is what's executing it. So technically, it doesn't really matter what your job is. Airflow is managing the work, right? It's a manager, basically. It's sequencing the things in order, and it's making sure that something that is dependent on another job doesn't get run before that. So you can have very complex graph of work that it'll take and it'll do for you. And as Will was mentioning, Airflow 2.0, you can run it as a scheduler on a distributed system like Kubernetes, I think, where it can do lots and lots of work for you in parallel, but it's not doing stream processing like NIFI, where in NIFI you're looking at the process working on a particular item of information. In NIFI, we're looking at a job completing, right? So that's kind of like, I would say, like Airflow is managing maybe tons and tons of data under one node in the graph, whereas NIFI is going to be operating on one item at a time on that particular graph. Does that make sense?
Yeah, that's also. Sorry, go ahead.
Compared to more like a Uzi, it makes me think of Uzi or maybe Luigi. I actually wanted to know, like, how does it compare with Uzi? Because Uzi did similar stuff, right?
Yeah. So again, it can actually work with Uzi, right?
Right. Oh, okay.
Yeah, it can work with it, but that's the thing. It's not. It's separate from the Hadoop ecosystem, right? You can use it to do stuff in Hadoop. You can use it to do stuff in Spark. You can use it to do stuff that you wrote in shell script. So it's agnostic of whatever the underlying system is where you're trying to execute a job.
Okay.
Yeah.
Yeah. Cool. More. Yeah, on Hadoop.
Cool. So yeah, David, you're saying a former client used NIFI to do a number of tests against code and software being moved into a sensitive environment. Yeah, you can use NIFI for a lot of really cool stuff. Another question from Sachin. I assume Airflow can help in elasticity, scale up or scale down based on resource availability. Yeah, you can. It depends on what you're trying to scale up. Are you trying to scale up the Airflow itself, or to use Airflow to then scale your platform? Because you could do that too. Sachin, could you clarify? You're muted. Maybe they're not able to unmute. Can you unmute Sachin?
Yeah.
Yeah. Okay. Yeah. Go
So
ahead.
what I was meaning is, if let's say I've got a number of Docker containers that I need to use, so can I ensure that if needed, Airflow can actually create new containers, new instances, or new virtual machines to spin it up based on how my resources are being managed with, let's say, cost management and things like that? I mean, just so
Yeah,
can
I
I
mean,
use it as a broader workflow management tool?
Yeah, absolutely. I mean, like, even I would say, and Will, correct me if I'm wrong, like even before Airflow 2.0, there's an operator for Docker operator, and I think there's even a Kubernetes. But basically, Docker client works with a particular Docker host, right? So if you have a Docker host, or like let's say you're using ECS, and you say run this job using Docker run, Airflow can basically say to ECS, run this Docker for me, right? And so that definitely is possible. And that doesn't even require Airflow 2.0. I'm pretty sure about that. Yeah. So, Will, did you want to clarify what Airflow 2.0 brings to the table?
Yeah, so Airflow 2 brings a bunch of sort of small quality of life things, but I think the big thing that's exciting is that the scheduler in Airflow 1, the scheduler is restricted to a single node, and the core scheduler does so little work that it's still extraordinarily scalable. But with Airflow 2, they've actually made it so that the scheduler itself is distributed So you can scale that up even larger. But as far as using Airflow to provide elasticity for cloud resources, you absolutely could do that. The way that you might want to approach that is writing a Python script, writing a DAG that checks the resource utilization of the whatever you're looking at. So checks the EC2 instance, and if it is at 60-70% utilization, it expands it. If not, it just ends. So you could do something like that. I'd be tempted to look into tools that are more focused on that auto scaling, but you definitely could do that in Airflow.
Yeah, like
Thank you.
what? Yeah, like for example, there's already auto scaling built into most of the native cloud providers, like AWS, Azure, and Google. However, and then there's also auto scaling things like Fargate for ECS or Fargate for EKS. So when it comes to hardware, right, Terraform allows you to manipulate the state of the whole cluster by just manipulating a value, a variable, and then applying it. Well, technically, you could have a DAG for Airflow that checks some load and changes the Terraform state, does a plan, and then executes the plan, right? Yeah, I mean, that's an interesting take on it. I think there's generally like that feedback loop for auto scaling and allocating resources. It's not as at least what I've seen as frequent, like where it goes up and down. But those things like up and down in terms of hardware resources, I think can be managed with auto scaling that's already built into the native cloud systems. If you need to do it yourself, Airflow could help you if you use it with something like Terraform. And Terraform has a provider for everything. Like it's got a provider for VMware, it's got a provider for even, I think, Packet, which is bare metal provisioning. It can like ask Packet to give you computers. So yeah, that's interesting. Yeah, Will, that would be cool. I'm down. I'm copying this message and putting it into my to-do system so I can like follow up with you on it. Very cool. Will said he's thinking about doing a talk on monitoring with Prometheus and Grafana. So I'm down. I'm putting it in the backlog. Awesome. Yeah, very cool. Thank you, Obi. Appreciate you going into kind of the demo aspect of it. Did you make that GitPod where you can just like run it and try it out on GitPod?
Yes.
Awesome. So there will be a blog post coming out with the GitPod link, which is yeah, and such, and yeah, it'll have all the resources kind of getting started with Airflow. But the cool thing that Obi has done is that you can go to the GitHub repo and click something called Get Started with GitPod, and it will bring up what you just saw in the browser. Everything that Obi was doing was in the browser. He was not doing it on his machine at all. So yeah, very cool. Any other questions? Awesome. Well, thanks everybody for joining. We can go ahead and stop the recording and just leave the thing open for people to kind of chit chat. This is something we lack in the Zoom world. I think I can actually stop the recording.